We are on a collision course in mutual descent towards our neighboring large galaxy Andromeda, also a system of several hundred billion stars. Our cosmic neighbor, the Andromeda Galaxy, is the nearest spiral galaxy to the Milky Way and is expected to collide with our galaxy. This event isn't expected to happen for another 4 billion years. However, a shocking signal has been sent back to Earth by the James Webb Space Telescope, showing that the collision will occur far sooner than expected. Furthermore, after a century of assumptions, the data from the James Webb Space Telescope has changed our knowledge of the Andromeda Galaxy by revealing startling and unexpected details about its true nature. This discovery has sparked a flurry of excitement and speculation within the scientific community. Is this an answer to our attempts at interstellar communication? Or does it indicate a celestial occurrence that is still unknown? And what happens when Andromeda strikes Earth in the Milky Way galaxy? Join us today as we explore the reason for the alarming signal received by the James Webb Telescope from the Andromeda Galaxy. Our galaxy, the Milky Way, belongs to the local group of galaxies and is a barred spiral galaxy. To find this galaxy, you would need to look up at the night sky in the direction of the star constellation Sagittarius. Its galactic center is very faintly visible there. All stars, nevertheless, are actually part of the Milky Way and are visible to the naked eye from Earth. The rotational speed of the Milky Way is comparatively faster than that of many other galaxies. Although there are billions of galaxies in the universe, this one has taken an astronomically long time to uncover and understand due to the restricted scientific instruments available at the time. Astronomers initially knew very little about the Milky Way. The first recorded observations of the Milky Way date back to ancient civilizations. The Greeks named it Galaxias C, meaning Milky Circle, due to its milky appearance in the night sky. However, it was not until the invention of the telescope that we began to understand its true nature. With the invention of the telescope in the early 17th century, astronomers like Galileo Galilei were able to observe that the Milky Way was composed of a vast number of stars. This was a significant step towards understanding the structure of our galaxy. In the early 20th century, the nature of the spiral nebulae was the subject of the great debate between Harlow Shapley and Heber Curtis. Shapley argued that the Milky Way was the entire universe, while Curtis believed that the universe consisted of numerous galaxies like the Milky Way. The debate was resolved by Edwin Hubble in the 1920s when he identified Cepheid variable stars in the Andromeda Galaxy, which allowed him to prove that it was indeed an independent galaxy outside the Milky Way. Edwin Hubble's work on the Andromeda Galaxy also led to one of the most important discoveries in modern astronomy, which is the expansion of the universe. By observing the redshift of the light from the Andromeda Galaxy, Hubble was able to show that the universe is expanding, with galaxies moving away from each other. This discovery formed the basis of the Big Bang theory. However, Hubble was not the first astronomer to notice this galaxy. Since ancient times, humans have been aware of the Andromeda Galaxy. The Persian astronomer Abd al-Rahman al-Sufi called Andromeda the Little Cloud in his Book of Fixed Stars in 964 AD. He was the first astronomer to see Andromeda with the naked eye. Before the invention of telescopes, however, it wasn't until much later that its full nature as a galaxy was understood. Astronomers sometimes call the Andromeda Galaxy by the name Messier 31 or M31. For a long time, astronomers believed Andromeda to be substantially larger than our own Milky Way galaxy. Recent research has brought about a reevaluation of these beliefs. Based on all available data, astronomers estimate that Andromeda is roughly 10 billion years old, putting it in the very early universe. Its age suggests that its development and evolution had a long and complex history. Compared to the Milky Way's 250 to 400 billion stars, Andromeda has around 1 trillion stars. Although it appears peaceful to the naked eye, astronomers have discovered a violent history and future within it. One of the most interesting features of the Andromeda Galaxy is its active galactic nucleus, AGN. The AGN is a highly active region at a galaxy center identified by strong emissions at a range of wavelengths, including X-rays and radio waves. The supermassive black hole located at the center of the galaxy provides the energy source for AGNs. These supermassive black holes are extremely dense areas in space with a large mass packed into a little volume. The supermassive black hole in the Andromeda Galaxy weighs roughly 110 to 23 million times as much as our Sun, according to estimates of its mass. It is thought that supermassive black holes like the one in our Milky Way are frequently found in the centers of galaxies. They have a major effect on the dynamics and evolution of galaxies. A fascinating theory regarding Andromeda's formation is based on the notion that it formed through a merger of multiple smaller protogalaxies. This implies that smaller galaxies progressively merge due to gravity over billions of years to become the amazing Andromeda Galaxy that we see today. These kinds of galaxy mergers are frequent occurrences in the universe, affecting the development and composition of galaxies. Recent observations and analysis by the James Webb Telescope have sparked speculation among astronomers that the Andromeda Galaxy might be undergoing a fascinating transformation. The signal indicates a possible transformation of the Andromeda Galaxy from a regular spiral galaxy to a ring galaxy with unique structures. The James Webb Telescope has also found that the history of the Andromeda Galaxy is similar to that of the Milky Way. Both galaxies have a single immigration event that dominates the inner halos. According to scientists, the Milky Way and Andromeda galaxies are headed toward collision and will eventually merge to form a new supergalaxy. At present, the Andromeda Galaxy is traveling at a speed of roughly 200 meters per second toward our Milky Way. Considering this, our merger will take place in the next 4.5 billion years. However, James Webb's evidence now suggests that this interstellar collision could occur far sooner than previously believed. The only reason the Milky Way and Andromeda will merge is that they became gravitationally bound to one another before dark energy took over. This enormous event has been nicknamed Mila or Mildromeda. Despite the cool nicknames, the effects of this merger would be disastrous for human civilization. The two galaxies' strong gravitational pull will cause them to distort each other's shapes as they get closer to one another. As black holes spiral closer together, the energy they emit in the form of gravitational waves becomes increasingly intense. These gravitational waves carry away orbital energy, causing the black holes to gradually approach each other over millions of years. The process of two black holes merging is a cataclysmic event, releasing a tremendous amount of energy into the surrounding space. This phenomenon, known as a black hole merger, is one of the most powerful events in the universe. When black holes merge, they create ripples in the fabric of spacetime known as gravitational waves. These waves propagate outward from the merging black holes, carrying energy away from the system. As the black holes lose energy, they move closer together, eventually merging into a single, more massive black hole. The merger of two black holes can have profound implications for the surrounding environment. In some cases, the gas and other materials surrounding the black holes can be drawn into the merger, forming an accretion disk around the newly formed black hole. This accretion disk can generate intense radiation across the electromagnetic spectrum, including X-rays and radio waves. The combination of gravitational waves and electromagnetic radiation produced by a black hole merger makes these events some of the most energetic phenomena in the universe. One possible outcome of a black hole merger is the formation of an active galactic nucleus, AGN. An AGN is a highly luminous region at the center of a galaxy powered by the accretion of material onto a supermassive black hole. The energy released by the AGN can outshine the combined light of all the stars in the galaxy, making it one of the brightest objects in the universe. The creation of an AGN through a black hole merger can have far-reaching effects on the surrounding galaxy. The intense radiation and energy produced by the AGN can heat and ionize the surrounding gas, triggering star formation and influencing the evolution of the galaxy. AGNs are thought to play a crucial role in regulating the growth of galaxies and shaping their properties over cosmic time. The merger of two supermassive black holes can also produce gravitational waves strong enough to be detected by observatories on Earth. In recent years, gravitational wave detectors such as LIGO and Virgo have made groundbreaking detections of black hole mergers, providing astronomers with new insights into the nature of these enigmatic objects. Studying black hole mergers can also shed light on the formation and evolution of galaxies. Supermassive black holes are thought to reside at the centers of most, if not all, galaxies, and their mergers may play a significant role in shaping the properties of galaxies over cosmic time. By studying the properties of merging black holes and their host galaxies, astronomers can gain valuable insights into the processes driving galaxy evolution. In addition to their scientific significance, black hole mergers are also fascinating objects of study in their own right. These cosmic collisions represent some of the most extreme events in the universe, where the laws of physics are pushed to their limits. By studying black hole mergers, astronomers can test the predictions of general relativity and other fundamental theories of physics in the most extreme environments imaginable. Overall, the merger of black holes represents a fundamental process in the evolution of galaxies and the universe as a whole. These cataclysmic events release vast amounts of energy and produce gravitational waves that can be detected across the cosmos. As we contemplate the fate of our solar system in the event of a galactic merger, it's essential to consider the profound implications of such a cosmic collision. The merger of the Milky Way and Andromeda galaxies will undoubtedly reshape the structure and dynamics of our galactic neighborhood, with far-reaching consequences for our own solar system. One of the most significant effects of a galactic merger on our solar system is the potential disruption of its orbit within the newly formed galaxy. Currently, the solar system resides in a relatively stable orbit within the Milky Way, located in a branch of the galaxy known as the Orion Spur. However, in a merged galaxy, the gravitational forces acting on the solar system could dramatically alter its trajectory. According to current calculations, there is a 50% probability that the solar system will be swept out 3 times further from the galactic core in a merged galaxy than it is now. This means that our solar system could find itself much farther from the center of the galaxy, potentially leading to significant changes in its environment and cosmic neighborhood. The implications of such a dramatic shift in the solar system's position within the galaxy are profound. The distribution of stars, gas, and other material in the galactic disk will be altered, potentially disrupting the delicate balance that has allowed life to thrive on Earth. The radiation environment, prevalence of supernovae, and other cosmic phenomena could all change with unknown consequences for the habitability of our planet. Moreover, the interaction between the solar system and other stars and planetary systems in the merged galaxy could lead to gravitational disturbances, perturbations in orbital dynamics, and even close encounters with other celestial bodies. While it's unlikely that any stars or planets will collide directly, the gravitational interactions between neighboring systems could have significant effects on the stability and evolution of the solar system. In addition to changes in its galactic environment, the merger of the Milky Way and Andromeda galaxies could also impact the long-term evolution of the solar system itself. The increased gravitational forces and tidal interactions resulting from the merger could destabilize the orbits of planets, moons, and other objects within the solar system, leading to orbital rearrangements and potentially even ejections of bodies into interstellar space. Furthermore, the merger could trigger a phase of enhanced star formation and activity within the newly formed galaxy, leading to an increase in the number of supernovae, gamma-ray bursts, and other energetic events. While these phenomena are unlikely to directly impact the solar system, they could contribute to changes in the cosmic environment and radiation levels experienced by Earth and its inhabitants. Overall, the future of our solar system in a merged galaxy is uncertain and complex. While current calculations suggest that the solar system may be swept out further from the galactic core, the full extent of the changes and their implications for life on Earth remain to be seen. As we continue to study galactic mergers and their effects, we gain valuable insights into the dynamics of the universe and our place within it. The Sun is located in a branch of our galaxy known as the Orion Spur. Our galaxy is divided into spiral arms, and our solar system would be right at this arm's fingertips if we were sent farther out. Additionally, scientists estimate that there is a 12% probability that the solar system may be completely expelled from the newly created galaxy at some point during the collision. What about life on Earth then? Will life on Earth continue after the merger? Well, in roughly 7.5 billion years, the Sun will grow larger and swallow the Earth, turning it into a red giant. However, the Sun's intrinsic brightness or luminosity will rise even before then. This will happen ultimately in a timeline of about 4 billion years as solar radiation reaching the Earth increases. Earth's surface temperature will increase, and we might experience a runaway greenhouse effect much like what's happening right now on Venus, the planet next door. Thus, there's a good chance that life on Earth won't exist after the merger. However, perhaps by then, Some people on Earth will have developed space travel abilities. It's possible that we will have abandoned Earth in our solar system. The view of Andromeda colliding with the Milky Way might still be available to us, although from a slightly different angle.